Section 15C, question number 4, page 369. The question asks us to consider this function y equals root x, quantity 3 minus x all squared. Okay, considered. And then in part A it asks us to show that the derivative equals a specific function, a specific gradient function. So which I'm going to do now. So we're going to find the derivative function, the gradient function, by taking the derivative or differentiating, and we will use the product rule for this. But first I'm going to rewrite this into exponent form again, as I've done in the past. So root x is x to the 1/2, 3 minus x all squared stays the same. So we'll take the derivative of the first part, bring the 1/2 down in front, we'll subtract 1 from the exponent to give me negative 1/2, and then I will do 3 minus x all squared plus, so that stays the same, and then I will leave the first part as it is and then take the derivative of the second part. So bring the exponent down in front, leave the inside the same, subtract 1 from the exponent, and then multiply by the derivative of the inside, which is negative 1. And then I'll just simplify this a little bit. So I get 1/2 x to the negative 1/2. Actually, maybe I'll do some factoring all at the same time. I've got 3 minus x here and here, so I will factor out the 3 minus x just as I factored out 1/2 x to the negative 1/2 from both of these. And so then what will remain from this is just 1, and then what will remain from this when we factor this is just 3 minus x, and then when I divide x to the 1/2 by 1/2 x to the negative 1/2, I get 2x, and then negative 1 times 2 just stays, so I multiply that by negative 2. And then I'll just simplify this a little bit more. So this 2 is already in the denominator. This negative implies this part will go into the denominator, and I will also multiply this together here. So I'll leave this 3 minus x, and then I'll have 3 minus x here, minus 4x, and that will be all over 2x to the 1/2. And then from there I'll just leave that 3 minus x out front, and then I'll simplify in here, so I get 3 minus 5x, and that will be all over 2 to the root x. So this is what the book asked us to show the derivative equals. So the gradient function dy by dx equals 3 minus x, quantity 3 minus 5x, all over 2 root x, as required. Question B asks us to find all the points, or all the x coordinates, or the x values, I guess, where there's a horizontal tangent. And the horizontal tangent occurs when the gradient function equals 0. Because the gradient function is the gradient to the tangent, and when that equals 0, then obviously the tangent is horizontal. Okay, so we're going to find the x coordinates. So I'm going to set this function that we just found equal to 0. And then when I multiply both sides by the denominator, I end up getting 0 equals quantity 3 minus x, quantity 3 minus 5x. And then if there are two numbers that multiply together to give 0, then either the first number equals 0 or the second number equals 0. And then now I can solve for x in both cases. So here, negative x equals negative 3, therefore x equals 3. and here negative 5x equals negative 3, and x equals 3 over 5. So those are the two x coordinates when there is a horizontal tangent. Next question is asking for which x values is dy by dx undefined. Well, dy by dx, this function here, will be undefined when the denominator is equal to 0, or because we got the square root, when x is less than 0. So the function itself, this gradient function itself, will be undefined when 2 root x is less than or equal to 0. So therefore, the gradient function will be undefined when x is less than or equal to 0. In question D, part D, they ask, are there any values of x where y is defined but dy by dx is not defined? Well, the function itself is y equals, just to remind you, y equals root x 3 minus x all squared. So if I look at this, I see, well, okay, well, if x equals 0, then y equals 0. And the reason why I chose 0 is because when I look at the gradient function, which is 3 minus x quantity 3 minus 5x all over 2 root x, then I see that, and this also stems from part C, where I knew that x is less than or equal to 0, so that equal part allows me to look at the x equals 0 here for the original function, and then if x equals 0 in this gradient function, then that will show me that dy by dx is undefined, because when x was less than or equal to 0 in part C, the derivative of the gradient function was undefined, and therefore when x equals 0, the original function is defined, but the gradient function is undefined. And then for part E, we want to look for, I believe, we want to see what the graphical significance is to our answer in part D. And the graphical significance shows that there will be a vertical tangent at x equals 0. So the point 0, 0 exists, but because the derivative function is undefined when x equals 0, therefore at x equals 0 there is a vertical tangent. And the gradient of a vertical line is undefined. So since there is a vertical tangent, I can say therefore the gradient of the function is undefined, since the tangent is vertical. If you're used to seeing gradient described as y step, step over x step, or other times people say rise over run, if there's 0x step and it's all y step, 0x step, then because the 0 is in the denominator, that means that it's all y step or all rise, 0 run, 0x step, and that 0 is in the denominator, which makes the function undefined, so that the gradient would be undefined at that point.